Hi everyone, welcome back to my number sense series. In this video, we're going to be talking about isosceles triangles and also a little bit of rectangles. So with isosceles triangles, there's one very important thing, and that is the definition of an isosceles triangle, but it leads to a lot more things than the definition. So the definition, as I'm sure most of you know, is that an isosceles triangle is a triangle where two of the sides are the same. Now, this has other very important implications. For example, it implies that these two angles are the same. And it also means that one of the most important things you can do when you see an isosceles triangle, this is almost always going to be helpful, is to drop a height. Because this height creates two right angles and two triangles that are actually congruent. They are the exact same triangle, just mirrored about this line. And this is the most important thing about isosceles triangles that we have to talk about. Now with isosceles triangles, there's also going to be a special kind of isosceles triangle. A triangle that is both isosceles and a right triangle. The isosceles right triangle. You might see it drawn like this. Pretend these two sides are equal. I just drew it kind of bad. But these two sides would be equal. And this triangle is very special in the fact that you can kind of think of it as, half a square. Maybe, a sandwich that you cut into two triangles. This would be an isosceles triangle. An isosceles, a right triangle. So this has side ratios 1, 1, and square root 2, or square root 2, square root 2, and 2, something like that. And this is 45 degrees because it's isosceles. And this is 90 degrees. So, because this is 90, these two must add up to 90 because a triangle's degrees sum up to 180, but also it's isosceles, so these two must be the same angle, which is why you can tell that they're both 45. And also, if you drop a height, just like we did here, just, the point of view is a little bit different. If you drop a height, it actually creates two more triangles that are also isosceles right triangles. And these two triangles, are once again congruent, and they are both similar, which is, a word that you'll maybe learn later, but basically they are the same shape as the original triangle. So that is the things that we will need to know before doing these problems. So the first problem is about an isosceles right triangle, and it asks, what is the area of an isosceles right triangle with a hypotenuse length of 8? Now what you need to know here is basically the side length ratios. Now if you remember our previous video where we talked about scaling up triangles, that is basically the idea of similar triangles. I'm just not saying the word similar, but basically if two triangles are shaped the same, their sides will be in a constant ratio. So if I have, for example, this of 1, 1, square root 2, I can multiply each of the sides by 2, and I'll get 2, 2, 2 square root 2, and this is a triangle that will be the same shape. Similarly, all I have to do is scale this up to have a hypotenuse length of 8. Because if it has a hypotenuse length of 8, then I'll know it's still an isosceles right triangle because it has the same side ratios. And that's how I'll know it's my actual triangle. So if I wanted to scale this up, I'll revert this back to 1, 1, and square root 2, because this is the ratio that people always talk about. 1, 1, and square root 2, and I want this to have a hypotenuse of 8. So what do we have to multiply all the sides by in order to make it a hypotenuse length of 8? Well, this hypotenuse is originally square root 2, and I want to make it 8. So I should multiply it by 8 over square root 2, which is also equal to 4 square root 2. Another way you can think about it is that you want 8 to be square root 2 times the leg length. So what times square root 2 is equal to 8? It's 4 square root 2, or 4 root 2, as I'll call it. So it is 4 root 2 and 4 root 2. So we have the two legs, and since it's a right triangle, all we have to do to find the area is multiply the two legs and divide by 2. So it's 4 times the square root of 2 times 4 times the square root of 2, which is 4 times 4 times 2 over 2, which is equal to 16. Now it's important to note, another way you can think of this is actually using this. We know that an isosceles right triangle is actually just half of a square. So, we could just calculate the area of the square and then divide that by 2. So what we can also do is imagine just this shape. Imagine that you have a square, and this square has a diagonal length of 8. Now, what we want to find is the area of this triangle, which again is isosceles right because it's half of a square. A square, though, is also a rhombus. And to find the area of a rhombus, you can multiply the diagonals and divide by 2. And since it's a square, the diagonals have the same length. So to find the area of the square, we can multiply 8 times 8 divided by 2, and that is the area of the square. But we want the area of half the square, so we divide that by 2 again, and we also get 16. So again, in math, all roads lead to the same answer, which here is 16. And that is how we handle isosceles right triangles. Important things to note when you do isosceles right triangles, basically just two things, the side ratio and the angles, that's it. Of course, we're not only going to deal with isosceles right triangles, sometimes we just get general isosceles triangles. And this is where this tip comes in, extremely useful. Always remember this, drop a height. Drop a height. Oh, so what do we have here? An isosceles right triangle, the base 12 and area 48. Now, when they give you a base and an area, the thing you should immediately think of is, what's the height? Because the area we get from base times height. So if we have the area and we have the base, we should be able to find the height. Now here we have base 12, area 48. So area equals base times height over 2, remember? So here, 48 equals base times height over 2, which means base times height equals 96. Since base equals 12, height equals 8. And of course, this is something that you'll have to get used to doing in your head, but here I will just write it out for convenience. Later, we might attempt these without doing it, all here. So now we know the height is 8. But how does this help us with finding the perimeter? Well, to get the perimeter, we need basically the legs of this, right? And to get the legs, what we have to do is use the Pythagorean theorem. Because if you remember, dropping a height creates right triangles. And so we can use the Pythagorean theorem on this right triangle that we've just created. It has a height of 8, so one leg of length 8, and what's the other leg? It's half of the base. It's half of 12, which is 6. So we have a right triangle with legs of lengths 8 and 6. Now you can use a squared plus b squared equals c squared here, but what you can also do is note the ratio of these legs. This leg is 8, this is 6. They're in a ratio of 4 to 3. 4 to 3, that's part of a Pythagorean triple. The most famous Pythagorean triple, the 3, 4, 5. This is 3 times 2, 4 times 2, so this hypotenuse should be 5 times 2, which is 10. Of course, you can do a squared plus b squared equals c squared. It's not that bad here, but this is just another thing that you can notice. And so we will get that the legs have length 10, and so the total perimeter is going to be 10 plus 12, which is 32. Now, next question, an isosceles triangle with base 18 and sides 15. So here we're kind of going the other way, right? We have a base of 18 and we have sides of 15. So we want to find the height because we want area. So how can we do that? Once again, we're going to have to do the same thing. We have to drop a height, right? And then we have to use Pythagorean theorem with the right triangles in order to find the base. Because, the height. Because the height is like a leg of a right triangle. So I'm going to draw the problem out here. But if you can, try to pause right now and solve without looking at what I'm going to do. Because if you can do this without using a pencil and paper, then it's going to be very, very easy for you during the contest. So here I have a base of length 18 and sides of 15. And so, of course, the first thing I'm going to do is drop my height. That is the most important thing you can do. So here's my height. Now, it's a right triangle, and the right triangle is the thing that I'm focused on. So what are the legs of the right triangle? Well, this one leg is 9 because it's half of 18. And what is the other leg? Well, I can find that out using the Pythagorean theorem. And once again, you can use a squared plus b squared equals c squared, 9 squared plus height squared equals 15 squared. But once again, notice the ratio of sides. The ratio of sides, 15 to 9, that's equal to 5 to 3. This is once again a 3, 4, 5 right triangle. This is 3 times 3, 5 times 3, so this is 4 times 3, which is 12. 9, 12, 15, 3, 4, 5 ratio. So 9, 12, 15, then we can find the area because we have the base and the height. Well, the base is 18, the height is 12, base times height over 2, 18 times 12 over 2 is going to be 108. So that is how we deal with generally isosceles triangles. Always, always drop a height, and probably you will apply the Pythagorean theorem because dropping a height creates right triangles. Awesome. Now, something that they're also going to test you on is rectangles, but rectangles are much easier because everyone knows how to work with rectangles. But we will do one problem here just to practice. And here, let's try not using any paper or marker or pen. So I'm just going to pause right now. Please try the problem by yourself, and then I'll explain it in a bit. Okay, so I'll explain it right now. If it has a width 5 and area 45, well, we know the area is width times length, so 5 times length equals 45. Well, length must equal 9. And so it has dimensions 5 and 9. So the perimeter is 5 plus 9 plus 5 plus 9, which is going to be 28. So much simpler than isosceles right triangles or isosceles triangles, because all you have to do is base times height. Now this last one is a little bit peculiar. It is an estimation question. So they want you to estimate the perimeter of an isosceles right triangle with area 5,000. Now, here we are going to need to know the decimal approximation of the square root of 2. But don't worry quite yet. First, let's figure out just what exactly in mathematical terms the perimeter is. If it has an area of 5,000, what does that mean? Well, if it has an area of 5,000, think about it. The area is base times height over 2, okay? So that means the area times 2 equals the base times height. In other words, the base times height equals 10,000. But also, it's an isosceles right triangle. The base and the height are the same length. So base times height, or in other words, base squared equals 10,000, which means base equals 100. So it is a 100 by 100. This is what we have. Now we have to find the perimeter. And so the perimeter, to find that, we just need the hypotenuse. And to find the hypotenuse, we use the ratio of sides. We know that an isosceles right triangle has a ratio of sides 1, 1, square root 2. So this is the 1, 1, square root 2. Here we have 100, 100. We should have a 100 square root 2. Remember, everything is just scaled up by a factor of 100, So it's the same shape, just bigger. Think of it like that. So now we can find the perimeter. Now the perimeter is going to be 100 plus 100 plus 100 times the square root of 2, which is 200 plus 100 square root of 2, but you can't write this because sadly they will not accept a 100 square root of 2. So you have to know the decimal approximation of the square root of 2. Now generally for any purpose, it is enough to memorize that square root of 2 equals 1.414. But actually generally, usually, it's okay to memorize just 1.4. It's only like a 1% error anyways. I prefer 1.414, but 1.4 generally works pretty good. And here it does work just fine. Because all we need is 1.4, so it's 100 times 1.4, which we know is about 140. So it's 200 plus 140, which is going to be 340. So not a huge perimeter actually, but a pretty monstrous area. So this is isosceles triangles and rectangles. And really, it's not too horrible. All it really requires is a bit of practice with the Pythagorean theorem and getting used to visualizing these diagrams in your head, these lengths, and dropping heights, and working with right triangles and all of that. So I would say the most important thing is to keep working with the Pythagorean theorem. Recognize your Pythagorean triples, because in contest, they're going to try to waste your time by using other numbers. But these numbers, more than likely, are going to be ratios that you already know. So always work on looking for those similar triangles. Remember the special things that make an isosceles right triangle and an isosceles triangle very special. The square root of 2 is approximately 1.414, and that is basically all you need to know from this video. So I hope that helped you guys a lot. Thank you guys so much for watching, and I'll see you next time.